Hello, friends, and happy Friday or happy Tuesday, depending on which group you're in. I hope you all are having a great day and that you're enjoying your virtual days. I'm coming to you live from Apollo High School, room 302, and it's Virtual Wednesday, and it's pretty quiet here today. But every now and then they play some music over the overhead, which is pretty funny. It makes me laugh. So if you hear any music while we're recording this, just chalk it up to someone in the front office playing some jokes on us teachers while we're here by ourselves on Wednesdays. So the last time we were together, we talked about what happens when we get a negative square root, or the square root of -1 being equal to the letter I. And I, if you remember, is an imaginary number. And we get these in quadratics when our parabola doesn't cross the x-axis. It could be hanging out down here, or up there, any one of those. But if it never crosses the x-axis, we need imaginary numbers to determine our roots. So today we're going to do some operations with complex numbers. And our operations are things like addition and subtraction and multiplication. We're going to skip dividing for today. So today we're going to see what it looks like when we do these types of things when we have an I in the equation. So the first thing that we want to talk about again is that the square root of -1 is what is equal to I. And the other I term that we are going to see today when we do our equations is I squared. Now, when we've been doing radicals, or when we've been doing square roots, we learned our exponent rules yesterday. We know that when something is squared, it means it is something multiplied by itself. So for I squared, we're going to take the square root of -1 times the square root of -1, or that's the same thing as the square root of -1 times -1. And when we have a square root, we're looking for pairs inside the radical to bring them out. So look, I have two sets of -1s, so those can come out. So we can get that I squared is equal to, these two can come out of the house, they have a date, -1. So again, I is equal to the square root of -1, and I squared is equal to -1. And those are the two I terms with exponents. We can call this I to the first power if you want to. These are the two I terms that we're going to be using when we do our operations today. So let's look at some examples. Whenever we're writing an operation with an I in it, it needs to be in this form. It needs to be an A plus B I term, where A is the real number and B is the number with I. So the real number always needs to come first and the I needs to come second. So if we had the expressions 3 plus 2I and 4 minus 5I, these are both in our standard complex form. An imaginary number can also be called a complex number. So let's see what happens when we perform our operations with this. So the first thing that we're going to do is we're going to add these. And if you know me by now, you know that I love to put things in parentheses because that helps us, that keeps us from making some silly mistakes. So when we add our complex numbers, we're going to add our like terms. And you can think of that I as a variable. When we are doing these, I isn't a variable. We know what that I stands for. It is the square root of -1. It has a real number that goes with it. But we're going to combine these like we combine like terms with variables. So I'm going to use red to underline my real numbers, R for R. And I'm going to use blue to underline my imaginary numbers. And then we're going to combine our like terms. So red and red, so we have 3 plus 4 gives me 7. And then we have 2I minus 5I. So 2 minus 5 is -3 with the I on the end. And that is our answer for adding those two expressions. Now let's take the same two expressions and subtract them. So again, I'm going to put them in parentheses because there's something that's going to happen in a minute. It's going to be really important that we have those parentheses around them. So if I have 3 plus 2I minus 4 minus 5I, I've got that our friend, this awesome -1 hanging out in here that I need to distribute to everything on the inside of these parentheses before I can complete this operation. So I'm going to distribute, and I'm going to rewrite my equation. So I'm going to have 3 plus 2i minus 4 plus 5i. Because we've distributed it, so now it's all in parentheses. And I don't want to put parentheses around here now because that looks like multiplication, and we're not multiplying. So let me get rid of those. So we have 3 plus 2i. Ooh, that was a big number. Big. 3 plus 2i minus 4 plus 5i. So again, I'm going to underline my real terms in red and my imaginary terms or my complex terms in blue. And I'm going to get 3 minus 4 gives me negative 1. And then I have 2i plus 5i, so that gives me 7i. Now hopefully you all are thinking right now, man, this stuff's super easy. I really like this for one of our virtual day classes. Well, my last step of multiplication isn't quite as easy, but I think you all are awesome and smart and you all can do this just perfectly. So now we are going to multiply the two expressions together. So we're going to have 3 plus 2i times 4 minus 5i. Alright, so we've done equations that look like this that have x in there recently. So we are going to draw our handy dandy box that we've been using. And we're going to put 3 plus 2i and 4 minus 5i. Now before we do this, I'm going to put these reminders up here at the top that I is equal to the square root of negative 1, and I squared equals negative 1. So those are some important things to remember when we're doing this problem. Alright, so now we're going to multiply. We're going to take 3 times 4 to give us 12. We're going to do 4 times 2i to give us 8i. We have 3 times negative 5i to give us negative 15i. And then we have negative 5i times 2i to give us negative 10i squared. Now we haven't had an I squared in an equation yet. So when we rewrite this, we're going to have 12 plus 8i minus 15i minus 10i squared. Now, if we were just combining like terms like we've done in the past, we can look and say, oh, the only two things that have like terms right now are the 8i and the negative 15i, and then we're done. But the thing is that we have learned that this part right here is right here. I squared is equal to negative 1. So I'm going to rewrite this one more time. I have 12 plus 8i minus 15i minus 10, and I'm going to replace that I squared with a negative 1. So anytime you see I squared, you're going to replace it in the equation with a negative 1 in parentheses, and we're going to multiply the term by that. So this becomes a positive 10. So we have, again, I'm going to underline my real numbers and in red and my imaginary numbers in blue. So 12 plus 10, because negative 10 times negative 1 is positive 10, that gives me 22. And then I have 8i minus 15i to give me negative 7i. And we're done. So that's an introduction to imaginary numbers. So now I'm going to show you what your homework today is going to look like. So you'll have a worksheet, and up at the top of your worksheet you're going to have some expressions. You're going to have x equals 7 minus 6i. You're going to have y equals negative 8 plus 3i. These are not the ones that are on your worksheet. I'm just making these up. And then we have z is equal to 2 plus 4i. Alright, so if you look at the first problem on your sheet, you're going to have x plus y. So I'm going to go ahead and underline my x equation in red, my y equation in blue, and my z equation in green. So for my first problem, I'm going to have my red problem plus my y problem. So that means that I need to rewrite this as 7 minus 6i, because I found my red problem, plus negative 8 plus 3i. Alright, so now we combine our like terms. We underline our real numbers in red, our imaginary numbers are in blue, and we're going to combine. So 7 plus negative 8 gives me negative 1. And then we have negative 6 plus 3, so that gives me minus 3i. And we're done. So maybe the next problem would look like y minus z. All right, y is our blue problem, z is my green problem. So I'm going to take this and do negative 8 plus 3i minus 2 plus 4i. And again, remember that we have to distribute a negative 1 or change the signs of everything in that second set of parentheses before we can combine our like terms. So this becomes negative 8 plus 3i minus 2 minus 4i. Again, we're going to combine our like terms. We've got our real terms in red, our complex or imaginary terms in blue. So we have negative 8 minus 2 gives me negative 10. And then we have 3i minus 4i to give me minus I. All right. And so maybe my last problem looks like x times z. So again, I've got my red problem and my green problem. So I'm going to do 7 minus 6i times 2 plus 4i. If we do our box, 7 minus 6i, 2 plus 4i. So 7 times 2 is 14. Negative 6i times 2 is negative 12i. 7 times 4i gives me 28i. And negative 6i times 4i gives me negative 24i squared. I should have made that box a little bigger. But again, we're going to do 14 minus 12i plus 28i minus 24i squared. And look, if you remember, we can go ahead and change this I squared to a, go ahead and change it when we write it down. If we remember, I squared becomes 24, ooh, that's green, 24 times negative 1, because I squared equals negative 1. Remember, this I equals the square root of negative 1. So we have 14 plus 24, because negative 24 times 1 is plus 24. So 24 plus 14 gives me 38. Again, those are my real terms underlined in red. And negative 12i plus 28i gives me 16i. Alright, so there you have 6 examples of operations with complex numbers. When you go to your worksheet on Google Classroom, you will see that there are 4 sections on the worksheet. You only have to do the top section that's in green. Those are the problems that I really want you to work on to be ready for class on Monday. But I'm giving you the option of doing more problems for extra credit. So if you're struggling in this class and you're feeling good about these operations with complex numbers and you want to do some more problems to boost your grade up a little, I will give you extra points if you do more of this worksheet than just the top section. But the kicker is that I need you to show all your work. I need you to show the steps. I need you to show me that you've written down the equations. I need you to show me how you're combining your like terms. If you want to write them down on a piece of paper and underline in different colors. I want to see your boxes. I need to see that you're not using a program or another person to do these. I need to know that you're absolutely understanding them. So I will give you extra credit for any problems you do beyond the green box. You have to do the green box. But after the green box, I will give you extra credit for every problem that you do correctly after that, as long as you show your work. That's the kicker. So if you have any questions, I'm always here to help. And I can't wait to see you all in class again. Hope you have a good day. Talk to you soon.